Okay. I really earned a giant paycheck. Actually teaching for like, I don't know, 4 hours today. Whew. That's a whole lot of talking, but it is. Okay, so the reason we have to learn how to expand and condense logarithms is so we can solve complicated equations like this. You guys already know how to solve an equation like log base 5 of x equals 2. How do you solve a simple equation like this?
Give it a swirly.
Give it a swirly. That's exactly right. You give it a swirly because, you know, how do you drop a log? You give it a swirly, okay? And so it turns out that the base of 5 squared is equal to x, which means x is 25. Okay. So you can solve a simple log equation like that. And you can see these are more complicated. And so what we want to do, our goal with every log equation is to make it as simple as possible. And so if you see something like a log plus a log, what do you want to do? Condense it into a single log. And so we are going to condense it to a single log. What property allows us to add the logs? The product property. And so that's going to be 5x times this argument here, the x minus 1. So we're using the product property in reverse. What do you suppose we need to do with this? Distribute. Good. Okay. So that's log of 5x squared minus 5x equals 2. All right, and now we have a single log. So ladies and gentlemen, how do you drop a log? Give it a swirly. Yeah. So what is the base then? 10. Oh, very important. So we have 10 to the second power equals what? 5x squared minus 5x. Very good. All right. 5x squared minus 5x equals 100. Very good.
Bring it over.
Bring it over. I like the sound of that. I'm going to condense a step here. So we're going to subtract 100 so that it's set equal to 0. And then what can you do?
Double bubble.
Double bubble. Is there anything else I can do before I double bubble? Factor. Well, the same thing. So divide by 5. I really like the sound of that. Can I divide everything by 5?
Yeah.
So that's 20 equals. And the reason I can just get rid of it is because we're equal to 0. So I can divide that side by 0 as well. And then now we can double bubble or factor, same thing. So x times x is x squared. What times what is negative 20?
X minus 5x plus 4.
Good. Negative 5, positive 4, which means x equals
5 or negative 4.
5 or negative 4. Interesting. One of these does not work.
Negative 4.
Why does negative 4 not work? What, the x can't be negative? Okay, so the argument cannot be less than 0. That's really important because I'll show you here. You can see in your calculator. We have a log, and what I'm going to do is plug in negative 4. Negative 4 minus 1. Error, non-real answer. Okay, we cannot take the log of a negative number. All right. So negative 4 doesn't work. We cannot take the log of a negative number. So we can't do the log of negative 5, which is what that turns out to be. That is a non-real result. Did we already graph logs in this class? No? Okay.
I'm still saying
That we will. It's next. Then I don't know. Yeah. So we'll graph those, I think, tomorrow, and you'll see. But 5 works out perfectly fine. That one's actually really good. All right. Here. What do you think we want to do? Condense, yeah, to a single log. So I have the logarithm of a single quantity. And so we can condense. What's going to happen? Is this a product or quotient? It's a quotient. We got that subtraction sign. So I'm going to set it up as the top and the bottom. What goes on top and what goes on bottom? 2x plus 1 on top, x minus 2 on the bottom. So condense into a single logarithm. Now, same idea. How do you drop a log? Swirly. All right. Start with the base. What is the base?
10.
All right. So 10 to the power of 1 is equal to.
Oh, 10 to the power. 10. Oh my gosh.
2x plus 1 over x minus 2. Good. So is equal to just the argument. Drop the log. Drop the log. All right. So 10 to the first is just 10. How do you solve that? Cross multiply. Yeah. So we're just going to multiply that x minus 2 to the other side. What does that give me?
Like
10x minus 20. Good. And then, let's see, I'm going to just move my 2 over, so it's 8x. Add the 20. And so x is 21 over 8. Which turns out would be just fine. We're not going to get any non-real result there, so it's fine. Questions on those? I have one more that's really easy.
One more example. One more.
No, one more.
Whoa.
Log of 4x minus 9 equals log of x minus 12. What's different about this?
There's an equals in the middle.
There's an equal in the middle. We can approach this a lot of different ways. But let me ask you a question.
Oh, you can just take the log out.
If the log of x equals the log of 5, what's x?
5.
This is the one-to-one property, okay? One-to-one property here. Since we have logs on both sides, if those match, what must be true?
There.
The arguments must match as well. So 4x minus 9 is equal to x minus 12 because the logs match. Now, the other way you could do this is we could actually subtract this thing and move it over and condense, and it's a lot harder.
Yeah, let's
Okay,
not do
let's not do that. So let's keep it easy. So I'm going to subtract an x, so it'll be 3x, add a 9. So x equals negative 1. Does negative 1 work?
no.
No, it doesn't. Why not?
Because
The argument is not allowed.
Yeah, the argument is not allowed to be negative. Log of negative 13 does not compute. Okay? If we take that negative 1 and plug it back in, we cannot solve this question. Okay? Cannot take the log of a negative argument. Sometimes the number can be negative, and that's fine, but when we plug it back in, the argument has to be positive. Okay? Awesome, ladies and gentlemen, do you have a question for me? Yeah. If I take negative 1 and plug it in right there, and then I try it on my calculator, log of negative 13. Whoops, log of negative 13. Non-real answer. Crazy, doesn't work. Okay? All right, ladies and gentlemen. You guys have class practice 5.
Alexander Dave Rocket.
There, I helped.
Oh, did it stop recording?
Yeah,
Yeah.
Oh, that's
It
crappy.
stops right after example 2. So
Did I
I'll-
not? I thought maybe there's like a maximum recording time per day. I don't know.
Good now is making it
Look at this.
Oh.
You stupid math. Yeah, that's what I'm doing. I know. I was planning on doing that. Let me guess, bitch, because it's like 2 fingers.
95 to 97. I was like, it's 2 fingers.
Oh my gosh, it's already 3 o'clock. Yeah.
It's 3 o'clock.
Yes, exactly 3 o'clock.
Miss, are we taking this long?
Yeah.
Why are we done this to us?
What do you want to do?
No, I would do the whole assignment today. Yeah.
You can't do the whole sign today.
No, yeah, get home.
I was just
Everybody else.
Hello.
Is this stuff easy or hard?
I mean, if you know properties and stuff like that.
I'm just checking. You're doing really well at these, so I'm impressed.
I had a picture of it.
Joyce, you feel like the first 2 like 75. Is it just asking which one we have to do after 8?
Dude, I did 85.
I think
Okay, so
This is just like
I know, sometimes I And
so.
very good thinking.
ah.
No, so remember, you first have to condense it into a single log.
Oh, to condense it. Got it. No, because when you plug it back in, this is an answer. When you plug it back in, so negative 4 thirds plus 4 is a positive 4.
Okay.
So when you actually plug it back in, it's still going to cause an argument.
Okay.
Are we condensing to a single log?
Yeah.
Does that make sense? Like, I see lots and lots of logs. Wait. Oh, I got you. Okay. Oh, I see. Okay, good. Great. Yeah. Good.
Sorry, Chris.
Yes.
Oh, we're not doing fractions.
So, yes. So really,
You know how much you walk?
Where's mine? 9.
no, this
Yeah,
is
yeah, yeah.
Eyes are
y to
closed,
the
I
1/3
think.
and you need to
You
drop
trying to
it
get
down.
after me
X to
sometime?
the 1/2.
You can get it to a
So
forward.
you're one
Oh,
step
really?
away from.
Well, I should be wrong. Yeah. You can get it higher, but you can never get it.
Mhm. Nope. Those parentheses aren't doing anything. Yeah, you can just drop them.
What did you get? You
So top, bottom, bottom.
Oh, okay.
Okay, yeah, that's.
Oh, I forgot that there was a. Ow. You got 19 over 8. Right? I know the one stuff. There's a one. So like, you have to get along on one side.
Adrian, for when you want to get this,
You know, like,
you can make a number.
plug it back. So it's plugging here. If you plug it back in, You get 1 in one bracket, and you get 3 in the other bracket.
That's a one. Yeah. So really those are.